Hello everyone, welcome back to the class 9 NCERT Mathematics. In last video we have done chapter 1.1, so we have just started the mathematics of class 9. So today we will see chapter 1.2. This is smaller. In last video we have seen the number system, starting the number system, what are natural numbers, what are whole numbers, what are integers, and what are the rational numbers. So chapter, what are irrational numbers? So we'll see what are irrational numbers. Now if you complete the irrational number, the complete bucket of numbers will be completed, like natural number, whole number, integers, rational and irrational. So first let's discuss about the definition of irrational numbers. A number S is called irrational if it cannot be written in the form of P by Q, where P and Q are integers and Q not equal to 0. So if it can be written in the form of Q by Q, P by Q, then it will be rational. And if it cannot be written in the form of P by Q, then it is irrational. So there are many rational numbers, indefinitely many rational numbers, as we have discussed. In the same way, there are indefinitely many irrational numbers also. So irrational numbers were discovered by Pythagoras, and the first number which was discovered by was root 2. Know the value of root 2? 1.414. Later root 3, root 5, root 7 were also declared as rational numbers. The proof of these irrational numbers, the proof of these irrational numbers are discussed in class 10th. So in 9th, you will only just know what are irrational numbers, the definition, not the proof. There are indefinitely many rationals and irrational numbers. Some of the examples are root 2, root 3, root 5, pi, 1.011, something like this. So what's given in your book. So these are the classifications of irrational numbers. Now we have done with whole numbers, natural numbers, integers, positive integers, negative integers, rational numbers. The collection of rational numbers and irrational numbers together make the collection of real numbers denoted by R. So now this R is called the real numbers. So the number line, that's why the number line is called the real number line, because in number line you can place anything. You can place whole number, you can place integers, positive integers, you can place negative integers, you can place rational numbers, you can place irrational. How to place irrational number I will show you. So this number line is called the real number line, because every numbers you can place on this number line. Now the collection of real numbers is denoted by capital R. Now the first example, locate root 2 on the number line. How will you locate the root 2? So you know what is the Pythagoras theorem. It is the hypotenuse. How to obtain the hypotenuse? The square root of base square plus height square. So in this, OA is the base and AB is the height. So OB will be your hypotenuse. It is square root of OA square plus AB square. 1 square plus 1 square will be root 2. Now how to place this in the number line? Make a number line. This is the negative side and this is your positive. So make one unit towards positive and one unit towards this side, and the square root, sorry, and the distance OB is your square root of this and this. Now how will you obtain? You keep your compass here, keep your pencil here, and draw the line from this point to this point. The point matching with the number line will be your the value of root 2. So you just keep your point of the compass here, pencil keep here, and draw a line. the arc. The arc where it meets the number line will be the value of root 2. And you know the value of root 2 is 1.414. So it is between 1 and 2. Somewhere between 1 and 2. Now we see the next question. Locate root 3 on the number line. Same way, how will you locate root 3? From the above, you know this is the root 2. So how will you find the OD? Why only OD? So you know how you can write root 3. You can write root 3 by this way only. Square root of root 2 square plus whole square plus 1 whole square. So it will be square root square of root 2. Square of root 2 will be 2, because this is written like this. Root 2 means to the power 1 by 2. 2 to the power 1 by 2. Again, if you square this, it will 2 to the power 2 by 2. This will cut and 2. This is how root 2 is treated. So you can write root 2 like this only. Root 2 ka square, root 3 like root 2 square and plus 1 square. 2 plus 1 root 3. So this one will only be the perpendicular, will only be drawn from the base, will be perpendicular to the base. This now this is your base. In this case, this is your base. Root 2 is your base, and this will be perpendicular only. So don't be confused. We have not drawn here anywhere, this side, that side. So this one will only be. So this is the base and this is the height. So you have found the root 2. So now root 2 is your base and 1 is your height. So one height will be 1 unit perpendicular to your, making 90 degree to your base. Now the value of OD will be, I think you understand, this is the root 3. Similarly, keep your point of compass here, keep your pencil here and draw the line. This somewhere it will meet here with the value of root 3. Note the value of root 3 is 1.732. So I hope you understand this question. Now next, we'll come to the exercise. There are only 3 or 4 questions there in exercise. This is a smaller chapter. After that, we'll move to the next chapter in next video. Now state whether the following statement are true or false and justify your answer. This is a concept building type questions. If you have the right concept, you can write the solution. Every irrational number is a real number. Yes. Right now, I've told that real number is a collection of whole number, all the numbers, integers, natural numbers, whole numbers, rational and irrational. Since the collection of real numbers is made up of rational and irrational numbers, so every irrational number is a real number. Now look, this is important. Every point on the number line is of the form of root m, where m is a natural number. This is false. Why? Every point on the number line represents a real number, but not every real number can be written in the form of root m. Every real number cannot be written in the form of root m, where m is the natural numbers. How? We'll show this. First, 3 is a point in the number line. Suppose 3 is a point in the number line. 3 can be written as square root of 9 is 3, since 9 is a natural number. Now, why it cannot be written? I'll show there. 9 is a natural number and 3 can be written as the square root of 9. However, consider the number 1 by 2 is also a point on the number line. This is a rational number, so this is also a point on the number line. But 1 by 2 is not equal to root m for any natural number in natural number, because this would mean m is equals to 1 by 2 square 1 by 4, and 1 by 4 is not a natural number. So 1 by 4 is a real number. So how it comes? just squaring both sides, square this side and square this side. So root will be, this root will be cut with this, and m is equal to 1 by 2 square 1 by 4. So this is a tricky, just you have to understand it's a not true for all natural numbers. There will be some confusion, so just see this solution again and again and you will get to understand this. Now what is the third one? Every real number is an irrational number. So this statement is again false, as real numbers include both rational and irrational numbers. We have seen. So every real numbers are not only irrational numbers. Now question number 2. Are the square roots of all positive integers irrational? If not, give an example of the square root of a number that is a rational number. The square roots, no, this statement is false. The square roots all positive integers are not irrational. Suppose square root of 25 is equals to 5. Since 5 is a rational number, root 25 is rational. How? Because square root of a perfect square is rational. Perfect square means it can be by solving, it can be written in the form of p by q. Like square root of perfect square means 25 is a perfect square. So how it can be written? 5. 5 is a rational number? Yes, it can be written by 5 by 1. So square root of perfect square like 36. So its square root is 6. This is rational? Yes, it can be written as 6 by 1. And square root of non-perfect square irrational like 37. So this cannot be written in the form of p by q. So this is not a perfect square and it is irrational. So square root of all positive integers are not irrational. I know this is a different concept, but you have to understand like this only. So how root 5 can be represented on a number line? First you have to know how root 5 can be written. The value of root 4 is equals to 2. Root 5 can be written as 2 square plus 1 square. So 4 plus 1 and 5. So this is your base, this is your height. Sorry, 2. 2 square and 1 square. So 2 units. So make a number line. If 2 units from in positive direction and 1 making perpendicular to the base. So this is A, this is point B. So OB is equals to root over 5. OA square plus AB square. So 2 square plus 1 square is equal to 4 plus 1, 5. Now again keep your compass point here and your pencil here and make the arc. Where it will go? It will be the value of root over 5. So these are only 3 questions I think in chapter 1.2. So this is how you have to solve, and the statement questions you have to just pay the attention what is been asked in the question and what the concept is. Accordingly you have to solve the questions. So in the next video we will come with chapter 1.3 that we'll see there. So till then, keep studying, enjoy the holiday, complete the syllabus in the holiday as much as you can, because this my month is something that every student should utilize. Thank you. Have a nice day. Bye bye.